was sent to social media prison by an algorithm for the crime they didn't commit. These producers promptly escaped from maximum security social media stockade to the internet underground. Today, still wanted by social media, they survive as producers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire the Smash Team.
All right. And we are back to live streaming, folks. How you like them apples? And we are here on Twitch. Cheers for everybody tuning in. We appreciate your patronage. And let's talk about that for a quick moment. Having a little issues with YouTube as YouTube curtailed their Google Hangouts screen capture features and so on, allowing only live streaming from cameras and so on. So we had to change things around a bit, to say the least. So thanks everybody watching also on YouTube. Anyway, check us out in both places. We'll look at other social media in a moment. Please support the channel via the real funding for the channel, which is patreon.com/smAsho. And let's get into the space weather. Thanks again, patrons. By the way, the gold level is $9.99 a month. Get your space information first. And what do we need funding for? By the way, you can also fund us via PayPal. If you're wondering what we need funding for, it's for the mission, which is to assist, study, and report on the ongoing formation of unified theory of physics. And to do the rest of the things on this list of things. We're not going to get into it because we want to keep the video short enough. And let's get on to solar data. Looking at the local yellow dwarf here in 304 angstroms. There's about 9 hours worth. Not a lot going on, no sunspots, no significant filamentary activity. Coronal holes are fairly diffuse except at the poles, where they never go away. Here's a 171 angstrom view. Let's zoom in at the north. I apologize for the jerky display, as this is basically our Twitch live stream premiere. So look for all kinds of extra content coming now that we've got everything set up the way we want it. Here's the southern portion. Again, not a lot going on. We'll look at the magnetic complexity in a minute. 10.7 centimeter radio flux, still at, I believe, 70, 71. Head to spaceweather.com real quick and verify that, as I can't remember what the Space Weather Prediction Center told me. And they've got some noctilucent clouds up there. 10.7 centimeter radio flux at 70. And let's close the Space Weather Enthusiast dashboard. Look at the sun in terms of magnetism versus 171 angstroms. And there you have the fade out. You can see the way the 171 angstroms view shows the magnetic looping. And let's move on to more data, like the GOES electron flux, which is not significantly low. It's fairly basic, I'd say. Nothing to really write home about. And the relativistic electrons are in a fairly moderated phase here. GOES magnetometers are looking smooth over the past 24. We did see a little spike there yesterday, right around when we made yesterday's video. And here's the Gong 2 data. This is 2 hours and 1 minute old. We do see a kind of a magnetic pull happen here. You can see the whole southern portion of the measured part of the current sheet kind of looks like it jerks toward Earth there for a moment. Kind of odd, perhaps an anomaly. Or perhaps growth of the North Pole field On the other side, we do see some plasma suspension out there. You can see where these field lines look all jumbled up. Probably not a sunspot, although it could be. And we won't worry about it too much, as stereo A is probably not even in view of that yet. And here's a real-time solar wind. And we just saw the phi angle wildly shifting around as we did show prep. So there's, you got 280 degrees or so now. And a solar wind density 5.82 protons. A small ramp up over the past couple of hours there in the solar wind speed to 324 kilometers a second. And there's the data from ACE. Here's a geospace magnetosphere movie. And we're looking at 4 hours of data there, courtesy University of Michigan. Geospace model. Shout out University of Michigan Physics Department. Very smooth there. And by the way, we do see continued ionospheric anomalies. We'll get to it in a minute. We see big charge ups in the southern hemisphere and around the equator. But first, we're going to look at the ground magnetic perturbations here, a little closer to home. And not a lot of current induced, as that solar wind has been so steady. Bring that to the end there. And you can see a little bit, that small ramp up did cause a little bit of magnetic fluctuation there, mainly over the Canadian North Pole. A little bit of sudden induction looks like it happened there too, right? Right at that moment. And here's what I'm talking about with the ionosphere anomalies. We got 6 hours of data here. And you can see these odd charge ups in the southern hemisphere there. As summer is approaching, very wobbly charged up southern hemisphere ionosphere here, and continued anomalies at nighttime south-southeast of Hawaii. And shout out to Hawaiian viewers. All right, let's move on. KP index has been pegged at 0 for the last 12 hours. Let's look at cosmic rays. Something we tend to do when we see a KP at 0. So here's the Apatity neutron monitor. Nothing significant going on there. There's Barentsburg. Nothing to write home about there either. Athens is the next one we typically look at. We're doing it in alphabetical order, folks. Nothing too exciting happening at Athens yet. Mexico City's next. And there's the last 30 days of Mexico City. Small ramp up over the past 3 days. Here's Moscow. Quite in the middle of the range for the past 30. And we'll go to Oulu. Shout out to our Finnish viewers. Thanks for teaching me how to pronounce Oulu. Now, Oulu does see an uptick over the past 2 days there. And here's DOMC Antarctica. Nothing special there. Here's DOMB Antarctica. Oh! DOMB Antarctica failing to send data. By the way, we always link to this cosmic ray site if you want to monitor them yourself. Don't take our word for it. Let's go over the last 24 hours of earthquakes. As we typically do most days at this time, we've switched the format to only talk about 6+ magnitudes and deep quakes. And of course, if one happens in my backyard. So we see, here's a 4.2 at New Zealand. That's nearly 200 kilometers deep. That one looks like it's actually on the Northern Island. Shout out if you felt that quake. Here's a Tajiki quake, 4.3 magnitude at 137 kilometers. Here's a 5.9 at Vanuatu. I think that's the largest of the past 24. 258 kilometers depth. If that occurred at the surface, that would be over about a 7 magnitude quake, folks. That would not be good, as this is a tsunami-prone area. And you can see this one happened in fairly shallow ocean, near the island of Isingal. Alright, let's head back to the list. If my back button works. There we go. Alright. See some quakes on the west coast of the U.S. too, by the way. Now we do see this 5.1 that's quite far inland China. That one's right under my pointer there. I was looking at that earlier. That one's at 25.4 kilometers. Oh no. See, that's not what you want to do, folks. You touch that scroll wheel at the wrong time and kapow! Your view is busted. Alright, I apologize. So it looks like some other quakes around China there. Kind of odd. Perhaps a missing plate boundary is located there. And let's look at the windy.com pressure maps. And I don't know why the heck it is showing me that. That makes 0 sense, folks. 0 cents. I set this all up yesterday to center me at New York City. Anyway, there you can see the pressure zones at the current situation, and it is currently 4:25 a.m. Do you know where your pressure is? We'll let this advance. This should be set to the GFS model. This is now a forecast, folks. We let this advance 24 hours so people can see where their pressure zones are. Please leave a comment if you have any idea what that means, meteorologically speaking. And there's where pressure will be at 10 Zulu tomorrow, around the time when we made this video. Last 24 hours of volcanoes include Mount Aso producing a 5,000-foot ash plume. Please don't fly over that on your ultralight home-built helicopter. Mount Dacono, flight level 7,000. Fuego has dissipated. All right. Volcanic ash observed at Nevado del Ruiz. Sangay exploding, flight level 19,000. Please don't pole vault Sangay, which is located in Ecuador. Also Revenador exploding, 15,000-foot plume there. Sabancaya, flight level 24,000 there as it explodes. Nevados de Chilean also exploding, flight level 14,000. Please don't pole vault Nevados de Chilean or do a back handspring over it. Or don't do any gymnastics moves. Don't even do one of those hobby horse vaults. We need the views, folks. So don't end up in a volcanic caldera. Milky Way Galaxy team for the win. Here's where stuff is in the solar system. To help our viewers visualize reality, please leave a comment if you think the Earth is flat. There's where things will be, God willing, in 1 week. On 12/12. Have you completed your Christmas shopping, folks? Here's where stuff is above my head. I like to use in-the-sky.org. And we're going to talk about the Parker Solar Probe in a moment. But first we got to get to value-added services. Here's a teaser. Were you aware that the magnetics of the solar wind, when close to the sun, suddenly reverse and snap back in the opposite direction, and then snap back in the opposite direction again? Were you aware that we're on BitChute? As we had to have a fail-safe because of the possibility that our YouTube channel could get suddenly deleted for no reason with no explanation, as has happened to so many people. And we're not even sure why. Nobody really is, as I believe it's done by algorithms. Up to 53 subs on there. Nice job, smAsho staff. By the way, have you been watching Crank Yankers? There are new episodes coming out. If you like that show, good God, is it funny. I mean...
What's the status?
Yeah, Dennis, is this the lost and found apartment?
The security, they've lost and found. Yes, how can I help you?
Yeah, I got a little some over there. I gotta come and pick up, like to make sure it's there, come and pick it up, you know what I'm saying?
Man, oh man, good times. Anyway, check us out on Instagram. You'll see some exclusive content where, like, we make weird predictions about Google management without even knowing that it was happening. And let's get to the value-added services section so we can move on to crazy Parker Solar Probe talk. And we're not going to get too in-depth into it as there was a massive data dump. Anyway, there's where lightning is. Shout out Thunderbolts types. Northeast is still getting hit with some snow. And check out that zone over the Salt Lake once again. Wintry mix. It's an icy, salty, weird place. Let's go to the water vapor map. Get this video complete. As there's still plenty of things to cover. And I apologize if anybody's leaving comments. I cannot see the comments. So we will have this feature available at a later date. Anyway, there's a water vapor map, and I just want to focus this on Pennsylvania, actually. Now, I'm located in Lehigh Valley, but we've got a massive convergence going on right above my head, where there's a huge pressure gradient. If you think that's caused by carbon dioxide or from chemtrails, please leave a comment. We've always got room for kooks, and we never censor anybody, folks. No, please don't make a fool of yourself, because we will not delete your comments. Check out the Hall currents being made in the wet part of the air there. Absolutely unbelievable. And we will see some interesting cloud formations today. Look for the possibility of a second video. It's probably happening. Now let's also zoom in on the Salt Lake. As we see the opposite end of the spectrum, a low pressure system. Now we were just looking at a high pressure system. Here's a low. And you can see that counterclockwise rotating system there, just going across Utah. Today's weather pornography brought to you by the NASA GOES interactive weather satellites. And let's actually look at the cloud layer, because, again, interesting data showing up. I don't necessarily always zoom in, but we're expecting to see low clouds here, which are, by the way, a feature of cosmic ray flux. See, because as cosmic rays hit the atmosphere, folks, they refract and they end up hitting all kinds of different angles. So they could come in perpendicularly and end up at a very obtuse angle, or they could come in at an obtuse angle and end up perpendicular to the surface. Cosmic rays also do come in sheets and strings, not like beams like you would see in a textbook. And there you can see these obviously attenuated clouds. And it's not caused by HAARP, folks. The amount of wattage to attenuate that much water is greater than the capabilities of mankind, as the resolution on these satellites is 2 kilometers. All right, let's move on here to look at the jet stream. And there's the jet stream over the U.S. I apologize for you viewers in the rest of the world, as I can't analyze the entire globe. Actually, I can, but I don't do it yet because again, we need more funding. Look at this huge bend in the jet stream here. Huge bend in the jet stream right there over the California-Nevada border. And let's zoom out and keep this thing rolling as got to get to the Parker Solar Probe and then get the heck out of here as if we robbed a bank. Here's the Eastern Jets. And this is located at earth.nullschool.net, by the way. Don't take our word for it. Watch the meridional jet stream flow yourself. Shout out to David Devine for covering the coldest cloud tops ever measured. And thanks again, Smash team. Time for the bonus features. And again, thanks patrons. Please become a Patreon supporter, as we need to replace a bit more income to go full time. And it's happening. We're going to have game servers and all kinds of interesting features, including the forum on smashomash.com. Shout out to Ben Davidson on his video yesterday. Ben Davidson of Suspicious Observers. Most of our viewers are probably familiar. For those of you who aren't, check it out. Suspicious Observers. It's youtube.com/Suspicious Observers with a 0. Suspicious 0 Observers. Anyway, his video yesterday, he turned me on to a site I was not aware of. It's part of Colorado, University of Colorado, series.colorado.edu. And some interesting stuff here about early detection of solar flares. Now, one of the ways that we monitor this kind of stuff is by looking at the 245 megahertz radio flux, which comes from a little deeper inside the corona, then the 10.7 centimeter radio flux that we monitor daily. This is another way using magnetometers and so on. So that could be an article that you all will be interested in reading. And we will be incorporating some data from this possibly into the space weather videos. So look for that coming soon, as well as all kinds of other content now that we don't have to waste hours and hours encoding and uploading videos to YouTube. Citizen scientists deserve more credit. Were you aware? Well, this Cosmos magazine article apparently was, as citizen scientists are doing a large portion of what academics used to only do, thanks to tools like the internet. In some scientific scenarios, such as species identification, citizen scientists come up with all of the data. Shout out to Nick Carney for writing this brilliant article. If you're interested in doing citizen science, I got an idea for you. Check out zooniverse.org, the Galaxy Zoo project, where we need human beings to classify galaxies, such as this elliptical here. And we've got advanced workflow scenarios. I don't know what that means, but so check out Galaxy Zoo. It is the largest citizen science project in the world. It's not only galaxy classification. There's all kinds of other science categories in zooniverse.org. So check that out. We will eventually link to the Cosmos magazine article, depending on if you're watching live or if you're watching later on YouTube or on some other location. So we've got the first results coming back from Parker Solar Probe, and I didn't notice this when it happened, as I believe it happened on November 23rd. And it takes a while to digest this data, folks, so I wasn't even aware until this morning. One of the most interesting things that you're going to hear about are the instabilities in the plasma turbulence. The plasma seems to pulsate in an unexpected fashion close to the, I'll say, close to the chromosphere. And this is likely caused by a massive number of chemical reactions caused by the sun's electron availability. But without conjecturing too much, let's just move on and cite the article. Now, one of the big reasons that the Parker Solar Probe exists is because it's not well understood why the corona is so hot. And how about exothermic reactions? Perhaps endothermic reactions. Or what about both? Now, I know they've been finding elements there that they weren't expecting to find and so on. So let's just, we're going to be covering a little piece of this every day. So today the first thing we're going to talk about is the NASA article on November 12th, actually. All the data got released. I didn't see it in any of the science wires. And let's just say I read quite a few of those. In any case, the data's there. And here's some of the imagery from the WSPR, the Wide Field Imager, which shows very detailed images of the corona. This thing kind of looks out the side. And there's also a thing called ESIS, SWEOP, and Fields. And here's the information about that. The instruments that we have, the Fields, the Fields one is measuring magnetic fields, obviously. The electric field around the spacecraft with 5 antennas, which are made out of niobium, by the way, which can hold up to the obvious heat. It's a little bit warm out there, so. And part of the reason why the Parker Solar Probe has only recently been launched last year is because we didn't have the heat shield technology until just last year, and so now we have it. So this should cause leaps and bounds in solar physics and astrophysics to occur. This is one of the many reasons why science is getting rewritten. Parker Solar Probe is going to teach astronomers, cosmologists, etc., the way stars really work. We're hoping. Now, I know there's some conjecture about not having the right instruments on it, but so you've also got the WSPR, which is the Wide Field Imager. This is going to show things like corona. It's basically the only imaging instrument. It's the size of a shoebox, and it has to stay behind the heat shield. So we're going to show images of that on a later video. Here's the SWEOP, which is the electrons, alphas, and protons, which is going to count the most common particles in the solar wind, which would be mainly protons, also alpha particles, which would be helium nuclei, and of course electrons. So that's a very important instrument, this is a Faraday cup, by the way. It's able to pick up charged particles and so on. The thing glows red hot when it's doing its measurement. And lastly, we have ESIS, which actually has the Greek letter symbol for the sun in its acronym. I don't know why it's pronounced ESIS. It makes no sense to me. That one's to measure a wide variety of particles. There's what it looks like. Looks a bit like a sea urchin without the tentacles. So, some interesting data expected from all of these, and we're expecting to see, odd, unexpected heavy elements and all kinds of things. So look for a lot of information about that coming out. Lastly, the SciTech Daily article, 5 astonishing discoveries. They got to compress it a little bit because people have incredibly short attention spans. And let's play a clip, fair use style, from SciTech Daily's YouTube channel. We'll just get in here somewhere and put up 8 seconds. That looks pretty cool. Let's play 8 seconds.
Looks like in its early stages after its birth on the Sun. Parker found a transition point in the...
Now, there is a spot outside the Sun where we expect it to not be so dusty. That's one of the things that it looks at. So there's going to be a lot of interesting stuff coming out. Here are these kinks in a GIF animation. That's a pretty good one. You see these kinks in the solar wind. Probably because of magnetism, but in any case. Also, the solar wind rotates like children falling off of a merry-go-round. And so read the article. My favorite one out of all of these was the SciTech Daily one, despite my attention span being perfectly normal. Were you aware this is what the sun looks like from above? That there's an enduring coronal hole that's just there all the time, and if you just hung out above the sun without seeing the corona, now the corona is cropped from this image so you'd see rays coming out, but if you just looked at just the solar disk, that's what it looks like from above, folks. Seems strange? Yeah, I know. In any case, thanks smAsho team for viewing the smAsho stream. And stay tuned for a bonus feature. Oh yeah, we got to do it in real time though. You're going to have to see me get through the software, which I'm pretty good at. So it's being a retired pro gamer, it's very easy. As long as you press the buttons and they actually press. We're going to look at the sun in 94 angstroms. Now this view shows 5 times as many images as all the other ones, except I believe 131 or 131, I think, shows 10 images per minute instead of only 2. So this one, we're going to be looking at this more and more as time goes on, as we expect to see more solar activity kicking up during cycle 25. And welcome to cycle 25 and indeed the neo-renaissance. Here's the equatorial region. And only a little bit of magnetic activity there. No sunspots. Coronal holes are fairly diffuse. And the solar polar fields seem to be gaining intensity. Here's the southern region. We are out of here. Thanks again for tuning in, everybody. Remember to stare at the sun. Remember not to drink. And if you do, don't drive. Seriously, don't drive. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.